on running open source inference, not interference models in AKS using Kaito. So today you've got myself, Luke Murray, and George as well, but we'll delve into intros soon. So this session is ran on behalf of the Microsoft Azure Cloud Commanders Learning Room. So welcome aboard. Just some housekeeping. So just the recording, this session will just be recorded. If you do not consent to being part of the recording, then please disconnect your line. It'll be uploaded to YouTube for the people who can't make it to view today. The attendee names are hidden, so it's only if you start talking or want to share something, just be very wary of that. So just some inclusive session guidelines. Really, like, everyone's coming at this from a different perspective, especially with learning about cloud technologies in general and AKS. Some people may have been working with these technologies for 5+ years. Others may have only heard of them today. So just be very careful. All questions are welcome. Yeah, be nice to people. So let's get into introduction. So my name is Luke Murray. I'm the Learning Room host today. I'm also a speaker going to guide through what we've done in AKS and running the models through as well. So you can find me on my social media, but yeah, feel free to reach out. And we're blessed today also to have George. Do you want to introduce yourself?
Yeah, sure. Thanks, Luki, and yeah, thanks for organizing that. I'm a cloud developer advocate for the cloud native team. I work with products like Azure Kubernetes Service. I'm based in Melbourne. I work with the global team, with the community and the product team, and specifically more on the Azure Kubernetes Service. And yeah, let's go. And if you wanna share, that's my Twitter, there's also my LinkedIn where I'm more active. And if you wanna follow me.
Yeah, I'll put feel free to put any information into the chat, and in the recording, I'll put your contact details down as well. So thank you for spending, a couple of hours joining us today, giving us your experience and prepping and helping this. It's an honor to have you. So thank you.
Thanks.
Should we kick it off?
Yeah, let's get started. I've been doing similar, talks on AI tool that Microsoft's doing around the world. And the big discussion now is, and you probably saw it Build last few days, all the videos and being published about Microsoft Build event and all the new announcements. And the big thing now is reinventing, the applications using AI. There is a new AI PC coming, and how those new apps, to be built, and that wasn't possible before. I always think, that the new generation of applications now be guided by the new device and AI. And AI not just running on the cloud, but also running on the edge, running on your PC. And I think that's a big discussion that we're going to start today. And next will be, we have been doing last few years what we call modern app modernization, application modernization, and modern apps. And what that means all this discussion about microservice, about continuous integration, continuous deployment, because microservice now has more piece of software we can deploy faster. And then that's where Docker and containers come in place, and Kubernetes to help deploy those kind of applications that, using these modern development environment, principles. And then when we put this together with what we call now intelligent apps something that we start talking like a year and a half ago, Luke, and is kind of a new term that we created that
it's really taken over, right? Yeah, it's become almost an industry term now, intelligent apps.
Yeah, it is. And I think we did that at the Unite a year and a half ago. So, and then intelligent apps means, using AI, using natural language to talk, writing, could be video, could be audio now as well. We see all the announcements from OpenAI, from Microsoft last few weeks, and that's more than just the language now. Is like sharing even your environment. The application will be able to see what you're doing, and just go back there. You just go back one there, and then
Yep. So sorry. Yeah.
the point is like data driven, and they're going to see all the data, including image and audio and everything, and and now we're going to enhance that automation with the application and those components. And next, yeah,
It's
some,
I think the slides need a bit of coffee.
oh,
It's a
that's
bit
okay.
skewed,
Yeah,
but yeah,
to wake up.
it's still waking up. Yeah.
And the question is, the first question, look, is what the requirements for those kind of applications? We said one on the slide before that was data.
Mm.
The data will be very variable. There's no really structure on the data. Like I said, they could be getting anything, any information that can help. And it'll be very variable, the volume of traffic, the scalability of that. And most of those applications will be building to be global distributed, users, could be users anywhere. And we hours on real time. And how can we, which kind of platform we need to, to attain all those requirements that we have on those new applications. Then that's where Azure is building those like platforms that can support these kind of intelligent apps. And as you can see here on the cloud native platform, that pretty much integrates with whole Azure, security, AI, development tools, database, of observability like Prometheus, Grafana. And these also can all run on-premise using Azure Arc. Azure Arc is a way, is a single plane of glass, or you can control not just, cloud, you can manage multi-clouds and things running even on-premise. And on cloud native space, we have Azure Kubernetes Service. That's where I work more. And we create something now, Fleet Manager, I just won there before. Then, Fleet Manager that you can now manage multiple of those clusters that we call Azure Kubernetes Service. And then
And
go
you
next.
showed me a really great functionality of Fleet Manager yesterday, where, like, for example, today we're going to demo the pet shop application, but you showed me how, like, in my demo environment, I've only got the application running on one AKS cluster, but using Fleet Manager, you could easily deploy it to multiple. So, like, resiliency becomes a lot easier to obtain. Like, that's great.
Yeah, that's correct. You're going to see on the slide following, but it's kind of Fleet Manager is going to help you to, get your application being deployed across the globe. And we're going to leverage, Fleet Manager to be managing all those clusters spread in different regions on Azure, and even, on premise as well. That's going to help. I think it's important to understand, what's a cluster, but a cluster is nothing more than a group of, virtual machines that we do like a fully managed service for you. And then we store a Kubernetes cluster that's going to deploy your application, and you don't have to care where the application is running. They're going to find a spot where there is CPU and memory available on this group of machines, and they're going to install your application. And you don't have to patch the VM, you don't have to patch the Linux VMs or anything. It's almost a fully managed service. And we also announced, AKS Automatic, where you have less operation for you to do on this cluster. And Azure Kubernetes Service is like an API that you call and you ask them to deploy your application. It's pretty much that. And they're going to find, great endpoints, great space to deploy application, find a space to deploy your application. And when you look those new, not new, but those Microsoft platform like Bing, Office, Xbox, GitHub, and Teams, there's one thing they have in common. And if you click next there on the slide, you see that they all running on Azure Kubernetes Service. And Azure Kubernetes Service now hosts, most of all the new service that Azure are creating are based on top of Azure Kubernetes Service. Means that Azure Kubernetes Service is the foundation to all new service that Azure is creating. But the great thing is AKS is also valuable for the companies, for the enterprise companies to build their own platforms and to be very scalable and supporting all these AI, growth that's going to come in next few years.
It's one of those, like, this is definitely not a sales, type of meeting, but it's definitely one of those Microsoft eating its own dog food, right? It's offering the capabilities of AKS managed service, but it's also to customers, but it's also using it internally as well.
Yeah, when Azure started, Microsoft created one product called Service Fabric that was internal developed to support Azure. Still a lot of things running on that. And then when this open source project called, Kubernetes came, kind of starting building new service on top of AKS. And Xbox, like we have a popular game like Forza. Forza is running on AKS and not even using Linux containers, they're using Windows containers. We can have containers based on Windows as well. Then all the Forza game runs on top of AKS with Windows containers. And Teams is huge, like Microsoft Teams, imagining all these things running.
Yeah.
GitHub, when you run like a GitHub action, that agent that runs your pipeline on GitHub Actions is a container, okay, running on top of those platforms. And all the new Bing AI, all the Open AI that you're going to see. If you go next slide, I think that's where, OpenAI and ChatGPT was possible. And I don't know how many millions users they have, is a lot, 150, I don't know how many hundreds of millions of users. And, that scalability was possible using Azure Kubernetes Service and also, Azure Cosmos DB and have been developing on GitHub for sure. But that scalability, I think the first popular, scalable application using Kubernetes was Pokemon Go, the game.
Oh yeah, yeah.
Yeah, I think this when you're a student like game, if you like game, Pokemon Go was only possible because of Kubernetes. It was developed, using Kubernetes, deployed on Kubernetes, and when we had that explosion of usability and new users coming, hundreds of millions of users, everyone around the globe playing Pokemon Go, and they they had no crashes or anything because they'd be able to scale using the power of cloud and Kubernetes to scale Pokemon Go.
Got to catch them all, eh? Got to catch them all.
Yes. And it scaled down because imagine in the past.
Oh yeah.
Pokemon Go was very popular for a while, but after that was down. Imagine if you had to buy, hundreds of thousands of servers just to deploy that application, and after 1 year, 6 months, all you lose all the customers and they move to another game. And what are you going to do with all those CPUs and servers that you have there? It's very expensive. And with cloud, you be able to scale down as soon as you don't have enough users to play anymore. If you go next, and that's why I'm trying to explain a little bit what's Azure Kubernetes Service brings to the intelligent apps development space. And those are few like features on Kubernetes that are important for those kind of applications. And the first thing, you can work with any language that you want, any framework, as long as you can pack your application as a container.
Yeah.
And that's why you can play locally with Docker Desktop with containers. And look, I'm also a Docker captain. I'm going next week to the Docker Summit in Lisbon, in Portugal. It'll be amazing to to try to share more content on that space. But that's where containers is magical. Where you just pack your application as a container that can run anywhere, and not only works on my machine, works anywhere.
Yeah,
And
that's the first thought when I heard it as well, was works on, I've just deployed, this new Pokemon game. It works on my machine. So, and that's where the power of this stuff comes into play.
exactly, when you have those abstractions with containers, and now there's a new thing called WebAssembly that's going to change a lot as well, bring something more, new to the game. But containers, WebAssembly, those are the things that you have to look if you want to understand, how development is done now with containers and Kubernetes. And then the other things is you want to, integrate it with continuous integration, deployment the same way that we have for modern apps. And now you can use GitHub Actions, you can use, Azure DevOps and other platforms as well. No problem at all. Another thing that Kubernetes brings, like blue-green deployments. That's very important. Means that I have version 1 running. I want to deploy version 1.1 or version 2, but I just want to, swap those versions once the version 2 is ready to go. And sometimes it means that I need space to deploy version 2. Like if I don't have space, CPU and memory to deploy, I have to scale a little bit my cluster to make room for that. And then once the version 1 is removed and now I have just only version 2 running, you can scale down the cluster again just for that. Means that flexibility to scale up and down very quickly, could be even like a minute, depending on your configuration, scaling up and down. And we have also to think about that those deployments will be using ARM servers, ARM 64, and we are moving to ARM on the server very fast now. And if you are a developer, have a look. You can do ARM 64 on AKS. You can deploy application. You can deploy application with GPU, with Windows, Linux, and also Spot instance you can have as well. You can pay less. Spot instance on Azure is kind of a virtual machine that you only pay like a small fee, but Microsoft can ask you back that VM if they need it.
Yeah, it's mainly for when capacity, they have spare capacity, right? So
yeah,
until a more, pay-as-you-go customer comes along and says, I want that, then yeah. But it's really like for the type of workloads you're talking about, it makes sense.
Yeah. But if you compare that with virtual machine, how was that different from before? Before, for you to to manage like a group of machines, you need like a web farm, and it was very complex. And with Azure Kubernetes Service, we do all the patching, and upgrades of these Kubernetes components, and you don't have to care about that. All the observability, we now have managed Grafana, managed Prometheus. Those are the two components that are going to get all the the metrics, the logs that you need, and you're going to visualize on Grafana. Then you have these as a fully managed service on Azure as well, and all the security and all these things, those components. And but if we go now in for machine learning and AI, we have been running Azure Machine Learning on top of AKS for a long time. Then you could do build, train, validate, deploy, and monitoring, your machine learning and on Azure and also on premise using Azure Arc. But if you go next, you see that what we're doing now is, we talk about Fleet Manager and things, is we want to get your source code, from GitHub. We want to build your application, pack inside a container. We store inside that Azure Container Registry. That's just like a repository for the template of your container. It's called the container image. And then you're going to create this fleet of clusters across regions where we can deploy your application. You're going to see the AKS store demo here that looks going to show. We're not going to use Fleet Manager, I think, on this demo, on this real live demo here. Yeah. But keep in mind that you can spread the same application using things like GitOps, and you can deploy or even CI/CD pipelines. to deploy. GitOps is when the cluster go on your GitHub and get the application deploy without, you have to have credentials to connect to the cluster. It's kind of the other direction. The cluster is able to deploy the application themselves, and you don't have to deploy using a CI/CD. It's called GitOps. But you can use, GitHub Actions as a CD to deploy as well. And all these things integrate with, Azure OpenAI and things. That's how we unify this environment. But there's one component here that we call edge, and and also companies want to manage the Kubernetes themselves. They don't want to buy Azure OpenAI, where the model, like the OpenAI model, is deployed there, and they can just call API. They want to make sure that model is only used by them, even if OpenAI we have that isolation. But what's going to happen is they want to get those open source models and they want to deploy themselves. And that's where the demo is coming. If you go next, for you to get, like a model from, Hugging Face or somewhere, like a Falcon 7B, a Mistral, a Phi 3, those new models that could be large, but not that large, like 7 billion instructions or even these new small ones, like 2 gigabytes models or something. Where are we going to deploy? Now we can deploy. But if we talk about these big models like 200 gigabytes or 400 gigabytes, it used to take weeks, to do all this process to build a container image. That was a huge model. You have to download. You have to build the image. Then you have to find, GPU on the cloud available like Kaito. Then you have to make sure that they have an endpoint that they can access this GPU. It was very hard to do it. It used to take, weeks for them to prepare the environment just to, to try to work with those models. And now what we did, we create a new project. If you go next slide. We announced, a few weeks back or months, and was what they call a two-chain operator for AI, it's Kaito. And that's like an extension add-on for Azure Kubernetes Service. By the way, that's open source that we have this available that you can install, enable on AKS. And that's going to now create all this container image and run these models inside your AKS using GPUs in matter of minutes. I think maybe 30 minutes, less than an hour. Look.
It's definitely taken what you described, being able to host the models, create the endpoints, do internal testing. Like for me to get the demo that I'm about to show you today up and running, an hour, and you can go and do the same thing as well. So I think the hardest part was actually getting the GPU quota in order to run these, right? But this Kaito is amazing.
And Luke is going to show exactly that magic that this operator is going to create, like that workspace for you, where the model is running and you have an endpoint, and you just call that. Like all those steps that we saw before will be done like in a matter of minutes, and all dynamically, all inside AKS, using GPU, using Linux nodes, and all create dynamically. And that's a game changer. And it's things that people are building platforms on top of that. And that's how we see people running those models locally. And you can see the new AI PC now even running those models, small models, locally as well. Let's go for it. I think next slides. Thanks for that. I think that helps. And let's see Luke showing the magic there and see how that works in a demo there.
Yeah, thank you for that. It's all good information about how we got to where we are and what's running underneath, right? So in the demo today, we're going to use the Kaito Pet Supplies application. So this is an application developed by Microsoft for exploring and discovering AKS. Essentially, you can deploy it and it runs a whole bunch of pods that, display this application. So it's got a front end and a back end. In terms of the current setup that we've got deployed in my environment, it's got obviously an AKS cluster, and it's got a couple of services that it's running on. So it will do some ordering. So if someone wants, a pet supply of order of X, it'll go and do that automated running. So that's all happening in the background to display the demo environment as well, all within the AKS cluster. But what we're doing is we're taking this application and we've made it a bit more intelligent. So when you're going through and designing pet store descriptions as an example, then you want to be able to go in and maybe not do it manually. So the demo is set up currently with an Azure OpenAI endpoint. And what we want to do is really use Kaito to deliver that next step. So instead of it going and calling out an external API endpoint, which is running on Azure OpenAI, we want to do it internally with a Falcon B 7B model that's hosted within AKS itself using Kaito to deliver that. So let's discuss a bit more about sort of the technical details of Kaito. So Kaito's taking a lot of the heavy lifting that was explained earlier that could take months or weeks to really go and deliver by templating and offering a lot of the backend API services to configure things like the workspace, which is what your APIs are going to talk to. And the workspace will then hook into some custom resource definitions into the Kubernetes API, which allows us to talk to GPU node pools that are running our inferencing endpoint, right? So it'll be running our Falcon B model that comes from a public registry, but you could also have this directly from your own registry as well. So in this demo, it's like all we've done is we've pulled the Falcon B model directly from the public Microsoft container registry and set up the workspace. But you could host these models if you want internally in your own container registry as well. I think the other diagram has the private registry there, but one of the great things as well about the Kaito is really its ability to provision your nodes as required as well using the node provisioner. So the nodes are what the pods your containers will run on. So that's really your virtual machines or your virtual machine scale sets. So in the previous days without Kaito, you would have to go and either manually create the node provisions or stand up your node pools manually for GPU enabled. But using Kaito, you can actually have these node provisions create the right type of VM SKUs with GPU capabilities as you need them.
Yeah, look, when you use this private registry there, if you're using Azure Container Registry, we kind of doing lazy loading for those images. Means that even if it's a big size image, you're not downloading the whole thing at once, because those images they have layers of file system that Azure Container Registry now has stream
artifact streaming, right?
Artifact streaming that can provide this kind of lazy loading, and that's a big change, for like large image like models.
Yeah, which reduces the time that it takes.
Yeah.
Honestly, the biggest part, the longest part of time, and I'll kind of touch on it a bit in the demo, is the time it took to retrieve the image and create the workspace. There are some caveats, however, to Kaito, and it's really around it's made, you can't just go and take this technology and run GPT-4 or GPT-4o on your AKS cluster at the moment. Those models aren't supported. It's really about using open source models like Llama 2, Falcon B, Mistral, Phi, and run those locally instead. So it's trying to putting words in their mouth, but it's trying to take more of a vendor agnostic, but taking the types of models that you'd want to run in this kind of environment and enabling that as well. So not all models are currently supported, and these are the main ones that are. So Llama, Falcon, Mistral, and Phi. It also, there's two different versions mostly of these models that you can run as well, the instruct version and then the based version of the model. So in the demo today, we're going to use the Falcon B instruct model. The main difference between the instruct model and the normal base model is that the instructs are more trained for chat. So you send a prompt and then it comes back with the completion, where the models that aren't quite labeled as instruct are more, you could fine tune those for your own type of environment. But yeah, Hugging Face is a really good place for resources, and I'll put the links below on how you can find the supported models for Kaito as well. So let's kind of go through my creation of the pet store app. So we've gone, this is just a video recorded because it can take quite a bit of time to actually stand up some of the stuff. So the first part of getting Kaito and the pet store app up and running are being recorded, and then towards the end I'll flip over to the live version and I can show you kind of directly in. I'll have to skip ahead a bit because just wary of time, but what I'm doing at the moment is I've connected to a code space, so a GitHub code space on the AKS store demo repository. And what I've done is I'm using the Azure Developer CLI that's already built in as part of this example solution, which makes it fairly easy to stand up the cluster running the store app as well. I've essentially told it, and zooming in so everyone can see, but I've essentially told it to go, okay, I'm going to give it login to my Azure subscription. I'm going to select the region. So in my example, I'm in New Zealand, so Australia East is the closest region to me. I've already enabled the quota, but we can check to make sure that I've got available quotas in my subscription for the NVIDIA type machines node pools that I'll be running, and it's using Terraform to just connect to the Azure environment already from the Azure Developer CLI, and then create the environment for me. So just see if I can skip ahead.
In this case, look, you just so to be clear, you're just you create a Kubernetes cluster and you're deploying the application. You're not doing AI yet. You're just deploying AKS store demo inside.
That's right.
Azure Kubernetes cluster that you created there.
That's right. So the example is also going to deploy an Azure OpenAI endpoint as well, but we haven't done anything here around Kaito. It's just pet store application pointing towards an Azure OpenAI endpoint. There's nothing in here around using Kaito yet. So we'll just skip here because you can see the store demo is creating the Kubernetes cluster, the key vault, everything it needs to run to get that up and running.
Yeah, and on this application, like the way that they do is just they call Azure OpenAI to create a description for like a product.
Yep.
On the store.
Yeah, which is great because you don't need to go and manually go and do that because, yeah, there's a bias towards, you know, I'm creating a product description for a cat that has a hat. You may do things a certain way, but the using OpenAI becomes a bit more creative as well. So I can show you that. I think I've skipped a bit. Oh, so now it's created my endpoint for me, and I'm going to go into a test, which doesn't work here, but we'll just skip this part. So what I'm doing now is I'm going into the Azure. I will be going into the Azure. Now, here we are, into the Azure portal, and then finding the AKS cluster that's just been created. Innocent OO. I'm going to the services endpoint, and it's given a public IP. So store admin as an example, and this is the demo that's been created. So it's created the admin portal. The orders are running, so that's the backend services that are running as part of the demo as well. And I can confirm that it's created the cluster okay. Now I'm checking the SKUs. So I'll just pause this a bit. One of the main things you really need to consider when you're running these models locally within your own environment is, do you have enough GPU quota in order to provision these models in your AKS clusters for your node pools? So what I did is I went into the Azure portal and I did a quota request for the NCSV3 series for 12 the CPUs for GPU capabilities. Microsoft then came back and said, yes, Luke, you're not on the naughty list. You can have those GPUs. So yeah, you really want to make sure that you've got enough capacity, because a lot of these, like obviously, with the OpenAI endpoints, GPU capacity is at a premium, right? So this is when I'm actually doing my Kaito provisioning. So I'm creating a managed identity that I'll give access to allow Kaito in order to provision the GPU node pools. I'm then giving it contributor access to be able to do that. I think there was an issue here, but then I reran the command and it worked again. This is why live demos for this kind of things are always quite. Any questions, feel free to put them in the chat. And then I'm creating the OIDC issuer. So what that's really doing is creating the federated credential and allowing it to read the AKS cluster. What I found with some of my commands as well is that I really needed to make sure the scope was set correctly. And here I'm just checking to make sure that it's created my federated credential correctly. And now I'm adding Kaito to the AKS cluster for the Helm chart to allow me to pull that down and provision it for me. And setting the GPU provisioner, so it will be able to create our GPU-based nodes automatically for us. Just confirming that it looks okay and installing it. Status deployed. Now I'm installing our workspace, which is what we're going to inference and talk to for the Falcon model. Thanks for sharing that in the chat. Just wary of time as well, so I'll just skip. And now what it's actually doing is creating the workspace, which is creating our NVIDIA-based GPU node pools. As you can see, it's creating one VM. And I can see the workspace and the GPU provisioner starting to appear in my workloads. And now this is the part that takes a while, is actually creating the workspace. So within the kubectl get workspace, Falcon B instruct workspace, in the pets namespace, we're really waiting to see what it comes back with. So this is the step that Kaito is doing to actually create the workspace for us. And in the background, what it's doing is it's going to the public registry and it's grabbing the model, so the Falcon B model, and it's bringing that back into our environment for us, and then creating and standing up those endpoints. And this is the process that takes the longest amount of time. And in my example, it was about 40 minutes plus to create, which is why this is recorded and not just me doing it live. So you can see this jump from 58 seconds to 61 minutes, me constantly doing it. There was an issue in the with the minge endpoint in the back end as well, but I was able to fix that.
Yeah, and reminder that you can create multiple workspace and on the same cluster means that everything you have done so far before the workspace is just a preparation. Then after that, you can have multiple, and if for each workspace, they're going to dynamically allocate those machines and creating like pools, what you call node pools, or like pools of machine just to run like your workload.
Yeah, it's quite cool how you can do this, and I think you touched on it earlier as well about like these models at the edge. Like, so instead of having to go off to the cloud all the time, this is where the capabilities really start to play, being able to run your cluster and being able to inference it. So yeah, I'll just stop here. But this is really the workspace saying, yep, the resources are ready. So the node's ready, which is usually the earliest to get going because it doesn't take that much to stand up a node pool of GPU. The inference ready endpoints is really about, can I access the endpoint in order to do an API call and look up? Can I prompt it and get a response? And that's doing a check for me. And that's now available true, so I can use it. And then is the workspace ready as well? So all those three, you kind of have to wait. And yeah, 81 minutes. But like I said, I did run into a managed identity issue. I do have a blog article as well on this exact same topic, and there's hints as well in the blog article on how to have a look at the logs, what's happening underneath it, because obviously when you start to look at this as a demo, there may be stuff happening in the back end, and it'll be great to actually have a look at what's going on. So I'll put the links to the blog article as well. So once that's ready, we just want to do a quick check. And so what I'm doing here is I'm running a kubectl command to run a namespace curl command. So it's really going, is my workspace called workspace-falcon-7b instruct created by Kaito for us, is it accepting in the chat endpoint? So if you were calling Azure OpenAI, this would almost be exactly the same. So, and I'll show you what that looks like in the portal in a sec. And my prompt is, how can I make a cinnamon snickerdoodle ice cream? So my latest hobby is making ice cream. And let's see if it's working. So this is me prompting the cluster workspace directly. So it's not going to Azure OpenAI, and it's come back saying, here's a recipe for cinnamon snickerdoodle ice cream, so I know that it's working. So I'm going to get out of the recorded demo now and show you really what it looks like. So after I've got Kaito up and running and I've been able to inference that workspace directly, we've got the admin portal listed here. So if I go into, this is the cluster running, and I go into products, and I go add product, and I call it a hat, and then my keywords a cat, and I ask it to ask an AI assistant. It automatically went out. In this case, it's the Azure OpenAI endpoint because we still haven't flicked it through to the Kaito workspace yet. We're about to do that. And it's come back with a description. So what we can see here is within the AKS cluster, under configuration, we've got something called a config map. So within the pets namespace, there's an AI service config map. So this config map is a YAML-based file. Would you call them a manifest file, potentially? Or just config map that really sets what the pet store app is looking for. So if you're running this for a different type of app, which in most cases you would be for your own production or development environments, you would want to use this capability in your own intelligent application. You would have something similar. So currently it's pointing towards my OpenAI endpoint, which is this one, and it's using GPT-3.5 Turbo, and it's set to use Azure OpenAI. So what we want to do is we want to switch this to use a local workspace hosted. So I could go in here and just use Azure OpenAI to false, and then change the OpenAI endpoint from the public endpoint to my local workspace. I could do this manually, but what I'm going to do is open up a cloud space, Cloud Shell. And this is when you pray for the demo gods.
Mhm.
I'm going to confirm that my workspace can still be inferenced by running the command that I did in the recorded demo, which was essentially doing a curl command going, how can I make snickerdoodle ice cream, to my Falcon Bee instruct workspace. And in this case, unable to provide a specific recipe for that question, as it's not a common type of ice cream, which is really interesting considering I asked the same thing. And good news is that we know that it's working because it's come back with that prompt. Even though it's not a recipe for ice cream, we know it's working. So what we want to do now is change the config map instead to use our local large language model. And instead of the AI endpoint being the Azure OpenAI, we want to go straight to the chat endpoint of the Falcon Bee workspace. So we're going to use the kubectl command to apply this new config map. So I'll create this, copy this, and then what I haven't done yet, let's see if this works. It looks like it worked. What I didn't do is actually go and connect to the cluster first, but because I already logged in earlier, it's allowed that to happen. What I mean by that is going into the overview plane of the cluster and then going connect and copying directly to the cluster, which allows me to run the kubectl commands. Because instead of connecting to Azure as you usually would, which is the platform, this is connecting more to the Kubernetes APIs. So we can see that that's worked. So if I go back into my configuration again, this is where everyone screams at me and says, it's right there, Luke, it's right there. And I go scroll past it a couple of times. And then you can see that my AI endpoint is no longer the Azure OpenAI endpoint, it's the Falcon Bee workspace. And you can see that use local LLM is true. this should actually be false, but we'll see how that goes. So if we go back into our store application again, that's okay. That's what happens when I go directly. And then I go to products and I select add product. And I go hat. Oh no, bat. That's probably not the right keyword to choose. But if I ask AI Assistant, it will come back with that. So that's really pointing towards our new AI endpoint, which is our local version. So it's not using the GPT-3.5 Turbo endpoint. It's using our Falcon B workspace directly. And if I go use, just to make sure, I'm going to overwrite that, just in case there's, so use Azure OpenAI is false. So if I go back into the store admin, products, and it's come back with a description of, and it's quite really fast as well. So it doesn't have to go out of the AKS cluster and go and talk to GPT-3.5. It's instead talking directly.
Was very fast. Was very fast. And that's another thing. If you have requirements to be, you want to be your application more responsive, and bringing the model to run next to your application inside this same group of VMs on the same VNet is going to make this possible.
Yeah, so that's essentially the power of Kaito. It's really great. It's really fast. I'll go back to sharing the slides.
And every day we have like a new open source model, arriving. We have Falcon, we have Llama 3 now, we have Mistral, we have Phi 3, we have Phi Mini, that's very small one, have small, medium size. We have for all, the flavors. We have Vision.
I just realized that it's quite cold here, so I'm wearing my ugly Windows jacket, which is the Bliss theme, but of course my local desktop is also using the Bliss. But yeah, that aside, but going back, we can go directly into the Kaito Git repository, which is publicly accessible to everyone. And we can go and have a look at the models, the supported models that I was talking about earlier. So these are the workspaces that we've just referenced as part of standing up our demo and then getting the workspace and the node provisions within AKS. This is the one that I used. So I called the Falcon B instruct workspace, but it could be calling a Llama workspace or a Phi 2 model, potentially a Mistral as well. It really depends on your app and what that requires. But
I think that just the example, I'm not sure they have to see the supported modules there.
Yeah, they are here somewhere. I found them earlier. Let me have a look.
Because
these were essentially the commands I did as part of the demo as well, which was creating identity. There is the supported models here. I will find them. Here they are. So it's within the same repository, but it's under Kaito presets models. And then you list all the models that are supported, and then there's the YAML file as well. You can raise.
Can you show me that? Can you see this one? Have a look there. What's the versions that we have? Llama 2. Scroll down. Okay, Falcon 7B. Yeah, in some stage that's going to grow, and I think it's still in public preview. We're trying to make the things run, faster, but
I haven't
yeah,
tried that one. 40B, Instruct, Mistral, Phi 2. I was hoping in time for this we'd be able to leverage Phi 3, which came out a couple of weeks ago, but unfortunately it's not. But you can then link directly back to it. But you can, if there's specific models, small language models or large language models that you need to run internally in Kaito, the recommendation from the Kaito team is you can raise an issues. You can see here, someone's already submitted an issue request for an enhancement for Phi 3. So I was just mentioning that earlier.
yeah.
We want 5.3, and that enhancement goes into their backlog, and then they make sure that they can support it. They can run these things on their registry.
Yeah, that sounds good.
So I'll just go back.
Yeah, if you.
So, yeah, do you want to talk a bit
me-
more about the AKS community?
Yeah, we created like what we call AKS community. They have like a Twitter account. You also have the YouTube channel, where we publishing, all the content from the product team, from the partners, also from the Microsoft internal teams as well. And that's why if you can follow this channel, we just release a lot of videos from Build as well about AKS Automatic. There is a couple of Kaito videos there, or explaining, similar things that we did here, maybe more details and longer videos. And you can then follow the community. There's a new blog that was just released. And yeah, please subscribe and follow us.
Yeah, it's a great community. A lot of the videos are really good, especially this is how I originally found out about Kaito as well, by reading and viewing the videos the community and the product teams have put up. I believe AKS is definitely one of the more community focused product groups from Microsoft as well. So they run these local community calls, not necessarily in APAC friendly time, but they are there, and everything's recorded anyway. And for those who made it till the last couple of minutes, there, as part of Microsoft Build in the Learning Room community, there is a badge that you can get. So make sure you scan that and you enter in the redemption code of R7V2PJ, and you get a nice and shiny badge for your Microsoft Learn community, Microsoft Learn profile as well, for being a part of this. So this is part of really post-build events and keeping up to date. And I think as we kind of discussed with the Azure OpenAI and the AI inference and all this intelligent app capability, being able to really deliver and use this technology, not only using services like Azure OpenAI, but run this stuff internally in your own AKS cluster that's local and fast and within your control. Like, it opens up the doors to a lot more capability and a lot more business value, right? But yeah, I mean, I can finish up by saying thank you for joining us, and thank you very much for coming and spending your time. And is there anything you want to end with as well, George?
Yeah, thank you. No, thanks so much. And please follow the community. And thanks, Luke, for organizing that. I'm pretty sure it's a great community of students. If you want to record something with us, I have also a channel called Azure Cloud that I'm happy to onboard new speakers and student ambassadors and MVPs like Luke. Very welcome.
Yeah, thank you very much, and thank you for coming with us. Yeah, let us know what you what you want to see more of. But yeah, thank you very much.